So hello students. So we will be discussing about the types of reaction. Okay, and today we will be discussing about the fifth type of reaction. That is also the last type of reaction that is discussed in your first chapter. That is oxidation and reduction reaction. Okay, and these oxidation and reduction reactions are also togetherly known as redox reaction. Okay, redox reaction. So what is redox reaction? So oxidation and reduction reaction togetherly it is known as reduction reaction, redox reaction. Okay, so red come from reduction and ox come from oxidation. Okay, so that is generally we see that always oxidation and reduction occurs in the same reaction. Okay, so in a particular reaction, if there is oxidation, then if there is an oxidation of one substrate, then we will see that another substrate is also undergoing reduction. Okay, so that is oxidation and reduction generally occurs in the same reaction. So therefore, you togetherly name the reaction as redox reaction. Okay. So now, what are oxidation? What is reduction? So what is oxidation reaction? What is reduction reaction? So for that, I am giving you first the definition, or not exactly definition. It is what do you mean by oxidation reaction? Okay, if someone asks what do you mean by oxidation reaction? So oxidation reaction is a reaction in which one of the substance. So a substance means one of the reactant. Okay, where a reactant will gain oxygen, means it will get a oxygen atom. Okay, we will get an extra oxygen atom, or what happens if it loses a hydrogen atom. Okay, so in that case we say that oxidation reaction is taking place. So what is oxidation reaction? Oxidation reaction is a reaction in which a reactant or a substance, it gets one oxygen atom, extra oxygen atom, or it loses one hydrogen atom. Then we say that oxidation reaction is taking place. Okay, in different books, okay, or in high level books, or if you look on the books of class 11 12, you will get different definition for oxidation, different definition for reduction. Okay, so that you do not need for the time being. First of all, you understand in terms of gaining and losing of hydrogen. So if any substance or any reactant gets an oxygen atom, extra oxygen atom, or if it loses a hydrogen atom, then we will say that the oxidation reaction is occurring, and the reactant which is getting the oxygen atom or which is losing a hydrogen atom is said to be oxidized. That means the reactant which gets the oxygen atom, we say that that particular reactant is oxidized. Okay, and similarly in case of reduction reaction, if any reactant it loses an oxygen atom, okay, or if it gains an extra hydrogen atom, okay, if it loses an oxygen atom or if it gains a, this is not and, okay, this is not and, this is or. Okay, so if a substance or a reactant, if it loses an oxygen atom or if it gains hydrogen atom, then we say that reduction reaction is occurring, and the substrate which gets the extra hydrogen atom is said to be reduced. Okay, so the substrate which will get the hydrogen atom, we will say that that substrate is reduced. Okay, okay, so these are the mere simply definition of what is oxidation reaction and what is reduction reaction. Okay, so this is, I think, one of the most complicated type of reaction, and it is little bit complicated to understand. So I would request that please keep your attention all together in this video, so that you can get a better understanding. Okay, so first of all, now we have to understand two simple, very simple concepts: what is oxidation and what is reduction. So if you have a reactant, if it gets a extra oxygen atom or if it loses a hydrogen atom, then we say it is oxidized. If a reactant it loses an oxygen atom and gets a hydrogen atom, then we say it is reduced. Okay, okay, so this definition should be more clear to you once we start looking at the examples. Okay, so once we will start looking at the examples of oxidation and reduction reaction, this definition will be more clear to you to understand. Okay, so first we will be looking at oxidation reaction. So now look at this example. Okay, so here I have considered two reactions. This is one and this is two. Okay, so I am considering two reactions and this is simply a representation of a reaction. Okay, so here I am considering that AB is a compound, okay, and DO is another compound. Okay, so here AB is one reactant and DO is another reactant. Okay, and in this DO reactant we have an oxygen atom. Okay, clear? So AB is a reactant, DO is a reactant, and in this DO reactant we have an oxygen atom. Okay, so if in this reaction, if the oxygen atom is transferred to this AB reactant, okay, so that means the AB reactant gets an extra oxygen atom. Okay, so if oxygen is transferred to this AB reactant, that is, if this AB reactant is getting the extra oxygen atom from this reactant, this DO reactant, then in the product side we will get ABO. Yes, so that means what is happening, that AB reactant is getting an extra oxygen atom. Yes, so in this condition we see that this is a oxidation reaction. Why oxidation reaction? Because the one of the reactant is gaining an extra oxygen atom. So we can say that this is an oxidation reaction. Yes, and since this reactant, okay, this reactant AB is getting the extra oxygen atom, so we say that this reactant is oxidized. Okay, we will say oxidized. Okay, so which one is oxidized? AB is oxidized. Yes, so the AB reactant, it is getting the extra oxygen atom, and the reactant which will get the atom, which will get the oxygen atom, we will say that reactant is oxidized. Okay, so this is the first reaction, and now let us look at the second reaction. In this reaction, what is happening? That here ABH is one reactant and D is another reactant. Okay, so in this case what happens, that the H, okay, the hydrogen atom, if it leaves the ABH reactant and goes to the D reactant, okay, so if it leaves this reactant, that is ABH, and if it goes to this compound, that is D, so what happens, that then AB will lose this hydrogen atom. Yes, so AB will lose this hydrogen atom, okay, and it will go to D. So then we will get the product as AB and DH. That means ultimately AB is losing its hydrogen atom. Okay, so it may be also like this. Suppose ABH2 plus D. If we see that ABH plus DH. So in this case also we will see that here earlier we have two hydrogen atom and now one hydrogen atom is transferred to D. So one hydrogen goes out of the ABH2 reactant. So that means this ABH2 reactant, it loses a hydrogen atom. Okay, so if the reactant loses a hydrogen atom, then also we say that oxidation reaction is taking place. Yes, and the reactant from which the hydrogen atom is going, okay, the reactant, so here ABH, from this ABH reactant the hydrogen atom is going, so we will say that this ABH is oxidized. Okay, so if the reactant gets an extra oxygen atom or if it loses a hydrogen atom, then we will say that reactant is oxidized. Okay, so now we will be looking at reduction. Okay, so now we will be looking at some similar representative examples of reduction. Okay, so what was reduction? That if a substrate or if a substance or a reactant, if it loses an oxygen atom or if it gains a hydrogen atom, then we say that the reduction reaction is occurring. Okay, so let us take the first example. Okay, so example 1. Here, if here AB is a substrate and DH is a substance, that is AB is a reactant, DH is a reactant. Okay, So this DH reactant has a hydrogen atom. Suppose in the reaction what happens, if this hydrogen get transferred to AB, so then what will happen, that AB will get a hydrogen atom. So once AB will get a hydrogen atom, here will be ABH. Yes, so one hydrogen atom will increase in AB. So that means this AB reactant is gaining a hydrogen atom. So we can say that this is a reduction reaction. Yes. So in this case, what happens, that the reactant which is getting, okay, so which is getting or gaining the hydrogen atom is said to be reduced. Okay. So the reaction is reduction and the reactant which is getting the hydrogen atom is said to be reduced. Okay. So similarly, in this case, ABO is a reactant which have an extra oxygen atom. Okay. So in the reaction, if this oxygen gets transferred to this particular reactant, so that means the ABO reactant is losing a oxygen atom. Okay. So after the reaction, we will get AB and U. That is, this ABO is converted into AB by losing an extra oxygen atom. Okay. So then we can say that this ABO reactant is reduced. Okay. Why? Because in ABO, one oxygen atom is being loosed. Okay. So ABO loses a oxygen atom, and in the first reaction, AB gains a hydrogen atom. So in this both case, we say that reduction reaction is occurring. Okay. Clear? So in this reaction, I think your most of the concept is somewhat clear. So again, I will be discussing this with some examples. Okay. So let us look at the first example that is present in your book. Okay. So now we are looking at the first example that is given in your book. Okay. Or should I say, this is the only example that is given in your book of reduction and oxidation reaction in your first chapter. That is, in this case, what we are doing, we are taking copper. Cu stands for copper. Yes. So we are taking copper powder. Okay. And we are heating it. Okay. In general, room temperature, we are heating it. Okay. In general condition. So when we heat something, okay. So what happens, in the air, you already have oxygen. Yes. So in air we will be having oxygen. Okay. And now we are heating this. Okay. So in this reaction, what will happen? So due to heating, continuous heating, one of the oxygen atom will come to Cu. Okay. So suppose this reaction is like this, Cu, and we have here O2. Okay. So that means, what does O2 symbolize? That here we have two oxygen atom which are staying as a molecule. Okay. So what will happen? That one oxygen atom will come to Cu. Okay. So that means this Cu will get one oxygen atom. So when Cu will get one oxygen atom, it will form copper oxide, CuO. Yes. So here we have two copper atoms and here one oxygen molecule. So one oxygen molecule has two oxygen atoms. Okay. And here we have two copper atoms. So one oxygen atom will come to one copper atom. That means one copper atom will get one oxygen atom to form copper oxide. Okay. Since here we have two copper atoms, so it will form two copper oxide molecule. Okay. So now this copper oxide which is formed, it is black in color. Okay. So as soon as we heat the copper powder, we will see that some black color material starts to form. Okay. And that is copper oxide. Okay. So in this case, what we can see, that earlier in this copper we had no oxygen atom. Okay. So during the reaction, this copper is gaining oxygen atom from this oxygen gas which is present in the air. So that means to form copper oxide. So that means in this reaction, what happens, that copper is gaining an oxygen atom, and the reaction in which as a reactant gains an oxygen atom, we call this reaction as oxidation reaction. Okay. So this reaction, this whole reaction, we can say that this is an oxidation reaction. Yes. So why oxidation reaction? Because copper here is getting oxygen atom from this oxygen gas, okay, to form copper oxide. Okay, so if you are still having doubt, see this one, the initial state of copper here, and see here. Okay, so in this reactant you only have copper, Cu. Okay, and in the product you have CuO. That means the copper is getting an extra oxygen here. So that means the process where a reactant gave the oxygen atom or it loses hydrogen atom, we term those reaction as oxidation reaction. Okay, so here since the copper is getting an oxygen atom, extra oxygen atom to form copper oxide, we say this is a oxidation reaction. Okay, and since copper is getting the oxygen, so we say that copper is oxidized. So what is oxidized? Copper Cu is oxidized. Okay, copper is oxidized. Why copper is oxidized? Because copper is getting the extra oxygen atom. Okay, so I think this first reaction is somewhat clear. Okay, so now we'll be looking at the second reaction. Okay, so in the second reaction, what we are seeing that once this copper oxide is formed, we are now trying to get back the copper powder. So copper powder has a brown color and copper oxide has black color. Yes, so now we will try to get back the copper. So to get back the copper, what is done? To this copper oxide, hydrogen gas is added. Okay, so to this copper oxide we are adding hydrogen gas and we are heating. Okay, so when you are doing this reaction, what happens? The copper oxide, it has oxygen atom, yes, CuO, copper oxide. So this oxygen atom, this copper oxide loses this oxygen atom to hydrogen gas. Okay, so that is in this reaction the oxygen atom, it moves from copper oxide to hydrogen gas. So we can say that this copper oxide is losing one oxygen atom. Okay, and it is forming again copper powder and water. Okay, so that means in this case what you see here in CuO it has an extra oxygen. In this Cu, this oxygen is not present now. That means copper has lost this extra oxygen atom, and where it goes, this oxygen atom goes to this hydrogen gas. So what is this reaction? This is a reduction reaction. Yes, so this is a reduction reaction. Okay, so this process is reduction reaction. Why? Because copper is losing an oxygen atom to form copper powder. Yes, and what is reduced? Copper oxide is reduced because this copper oxide has lost one oxygen atom. So the reactant which loses an oxygen atom or it gains a hydrogen atom, we say that reactant is reduced. So here copper oxide is reduced. Okay, so I think up to now you are somewhat clear about oxidation and reduction reaction. Yes, but I have already told you that reduction and oxidation reaction are togetherly known as redox reaction. Why redox reaction? Because most of the time it is seen that when there is a reduction reaction, there will be also oxidation reaction in the same reaction. There will be also oxidation process going on in the same reaction. Okay, so if in a reaction, if one substrate is being reduced, then the other substrate is oxidized. That means in the same reaction, reduction and oxidation process works together. Okay, so why I am saying that? Now we look at it. Okay, so now look at this reaction. This is the same reaction that we have seen just a while ago. That is, we are adding hydrogen to copper oxide and heating to get copper powder and water. Okay, so in this reaction, just a while ago I have explained that copper oxide is reduced to copper. So the copper oxide to copper, in this process what is happening? Reduction. Yes, this is clear because what happens? The copper oxide, it loses this oxygen and this oxygen goes to hydrogen. So in this copper oxide, copper is losing the oxygen to give copper powder. That means copper oxide is reduced to copper. So this is a reduction process because copper oxide is losing its extra oxygen atom, and losing of an oxygen atom or gaining of a hydrogen atom is called reduction. So copper oxide to copper, this is a reduction process. Okay, and what happens? This oxygen goes to hydrogen. Okay, so now look at this hydrogen. In this case, what happens? This hydrogen is getting the oxygen atom. Yes, and we said that if any reactant gets a oxygen atom or if it loses a hydrogen atom, then we say it to be a oxidation process. Yes, so look at this hydrogen here. In this case, it has no oxygen. Yes, it is only hydrogen gas. It does not have any oxygen atom in it. Okay, it is simply hydrogen gas. But in the reaction, what happens? This oxygen atom, it goes to this hydrogen molecule. So that means this hydrogen molecule is now getting a oxygen atom. That is, it is gaining a oxygen atom to give water. Okay, so if you see here H2, here we do not have any oxygen, but here we have an oxygen atom. That means the hydrogen molecule is getting a oxygen, extra oxygen atom. And we say that if any reactant gets an extra oxygen atom, then it is an oxidation process. So for hydrogen to give water, okay, for hydrogen to give water in this reaction, so this is an oxidation process. Yes, yes. Why? Because hydrogen is getting an extra oxygen atom to give water, and copper here, it is losing an extra oxygen atom to give copper. So losing an oxygen atom is reduction and gaining an oxygen atom is oxidation. Yes. So in the same reaction, this is only one reaction. Yes, copper plus hydrogen, it gives copper oxide plus hydrogen, it gives copper and water. This is only one reaction. But in the same reaction, we are seeing that there is a reduction process and here there is an oxidation process. Okay, so that means in the same reaction, reduction and oxidation both are taking place. So such types of reactions are known as redox reaction, or if we extend it, reduction, oxidation reaction. Yes, so you can simply in short form, you can call it as redox reaction, or if you want to write it in details, then you can write it as reduction oxidation reaction. Why? Because in the same reaction, both reduction and oxidation process is going on. Yes, so here copper oxide is reduced to give copper and hydrogen molecule is oxidized to give water. Yes, so in one case oxidation is loosed. Okay, so copper loses the oxygen atom to give copper oxide loses the oxygen to give copper, and hydrogen gains the oxygen to give water. Okay, so this is why redox generally in case of oxidation reaction or writing as reduction reaction, we generally write redox reaction in most of the cases, because generally what we see that where there is an oxidation reaction, there will be a reduction reaction also, and where there is a reduction reaction, there will be an oxidation reaction also. Okay, so now let us look at these two examples. Here first we are considering H2S, that is hydrogen sulfide, and chlorine. Okay, so here you can see that in hydrogen sulfide, sulfur has two hydrogen. Okay, and in this reaction, these two hydrogen atom is transferred from H2S, that is from sulfur, to chlorine. Yes, so in this case you can see that before sulfur in hydrogen sulfide it had two hydrogen atom, and here there is no hydrogen atom. That means hydrogen sulfide is losing its hydrogen atom. Yes, and we know that if the reactant loses its hydrogen atom or gains oxygen atom, then the reactant is said to be oxidized. So in this case, hydrogen sulfide is oxidized. Okay, so that means from hydrogen sulfide to sulfur. So this is an oxidation process. Okay, and here in chlorine, what you can see that chlorine is getting two hydrogen atom from hydrogen sulfide. Yes, so here you see chlorine is getting an extra hydrogen atom. So if a substrate gets a hydrogen atom, then we say that reactant is reduced. Okay, so that means here chlorine is reduced. Yes, so this process from chlorine to hydrogen chloride, this is a reduction process. Yes, so we can say that reaction 1 is a redox reaction. Yes, why? Because hydrogen sulfide, that is H2S, is oxidized to sulfur, that is S, and chlorine gas or chlorine molecule, that is Cl2, it gains the hydrogen atom to give hydrogen chloride, that is HCl. Yes, so similarly in this case, that is heating of magnesium ribbon to give magnesium oxide. In this case also, what you can see, that magnesium here is getting oxygen from the oxygen gas present in air. So that means this magnesium is oxidized. Yes, so this is an oxidation process because magnesium is getting a magnesium is getting an extra oxygen atom. Okay, but here you see O2. Okay, in this case there was 2 oxygen atom. Yes, so O2 means there will be 2 oxygen atom because O2 is a molecule. So O2 molecule means 2 oxygen atom are present. Yes, together. But here you see that only 1 oxygen atom is present in NCO. That means the oxygen molecule, what happens? It gets reduced because it loses 1 oxygen atom. Okay, so one at a time. Therefore, we can say that this oxygen molecule is reduced. Okay, so both of these reactions are example of redox reaction. Okay, so I think your oxidation and reduction reaction is clear. Okay, but there is a small portion related to this oxidation and reduction or redox reaction, that is oxidation number. Okay, and oxidation number is associated with all the elements. Okay, so we'll be looking at what this oxidation number actually means. Okay, so now I am here trying you to explain what is oxidation number. Okay, so as per your syllabus you do not require what is oxidation number for anything about oxidation number, but still I am explaining you very briefly about what is oxidation number. Okay, so to understand what is oxidation number, first you look at this. Okay, so what is this? This is the electron drop structure of sodium. Yes, so electronic configuration of sodium is 2:8:1. You all know this because atomic number of sodium is 11. So its electronic configuration can be written as 2:8:1. Okay, so that means the valence shell, that is the outermost shell, will have only 1 electron. Okay, so what is valence shell? Valence shell is the outermost shell of an atom. Okay, and what is the valence electron? The valence electron of the electrons present in the outermost shell, that is the valence shell of an atom. Okay, so in case of sodium, okay, so this is the valence shell. Yes, and the valence shell contains only 1 electron. Okay, so for sodium to fill its valence shell, what we need? We need 8 total. Number of electrons should be 8. Okay, so we will be requiring total 7 number of extra electrons. Okay, then while discussing about valence shell, I have already told that it is impossible or almost near to impossible to get 7 electrons from other element. Yes, so maximum number of electrons that can be gained is 4. Yes, so maximum valency of an atom, we see that it is generally 4. Yes, if we do not consider the transition metals. Okay, so in cases of the main group elements, we see that the maximum valency is 4. Okay, so that belongs to the carbon group. Yes, so here in case of sodium, we know that valency is 1. Why valency is 1? Because to fill up its valence shell, we need total 8 electrons. Okay, so it has only sodium, it already have 1, so we need extra 7 electrons. So sodium cannot get 7 electrons from other element. So what will do? It will give this 1 electron to one other element, suppose X. Okay, to X, sodium will give its outermost valence electron. Yes, so then sodium will get this electron dot structure, that is the outermost, that is the valence shell. Now it will disappear because this will have no electron. Yes, so the other two cells now is completely filled up. The innermost shell, it will have 2 electrons, and the next cell, that is cell number 2, it will have total 8 electrons. That is both the cells are completely filled up. So sodium gets the electronic configuration of 2:8. So that is a noble gas configuration. So now sodium has a completely filled octet. Okay, but since sodium has given its electron, okay, so sodium is giving its electron. Okay, so that means since it is giving, we show down a positive sign. Okay, that means when it gives its electron, okay, sodium will form a ion. Yes, because electron consists of negative charge. Yes, and what we know, in an atom the number of electrons and number of protons is same. Okay, so here the number of atom, in this case the number of atom is 11. Yes, number of electron is 11, so number of proton will be also 11. Proton has a positive charge. Yes, so as soon as one electron goes out, so now number of electron is 10. Yes, but number of proton is 11 only. So overall charge is here, the overall charge is 10 minus, because charge of 1 electron is -1, so charge of 10 electron will be -10, and charge of 1 proton is +1, so charge of 11 proton will be +11. So now total charge is +1. Yes, so when an electron is given out, we will represent it as a positive ion. Yes, so sodium is a positive ion. Okay, so similarly, this is I think clear. So now in case of oxidation and reduction also, what we see, that when there is an oxidation, okay, when there is an oxidation, so here what we see, that its oxidation number increases. Okay, its oxidation number increases. So now what is oxidation number? This positive charge, you can consider it as oxidation number. Okay, so generally what is oxidation number? Oxidation number is generally the number of electron that is given out of the metal. Okay, so number of electron that is given out or that is taken, that we generally represent by oxidation number. So in this case, the oxidation number of sodium is 0. Okay, because it did not give any electron, or neither it received any electron. But in this case, oxidation number is 1. Okay, why 1? Because it has given its 1 electron. Okay, so what happens if, so we can say this is an oxidation process. Why? Because the oxidation number has increased from 0 to 1. Okay, so due to this, we can see that during an oxidation reaction, we will see that oxidation number increases, and during a reduction reaction, we will see that oxidation number decreases. Okay, so let us consider the reaction of copper plus oxygen. Okay, to give copper oxide. So this is an example of oxidation reaction we already saw. Okay, so in this case, what you can see, that always in a periodic table, metals always give positive ions. Yes, so they always have positive charges. Okay, and non-metallic, the non-metallic components or non-metallic elements that is present to the right side of the periodic table, they always give negative. Maximum of time they give negative ions. Yes, so in this case, what happens? You will see that copper oxide. Okay, so you will see, we know that here copper oxide is oxidized to copper. Sorry, copper is oxidized to copper oxide. Okay, so in this copper oxide, that is CuO, here there is no charge. Yes, so that means CuO is neutral. Okay, but we also know that oxygen, it gives it when it forms ion, it gives O2 minus ion. Okay. Okay, so in case of CuO, you see that CuO is neutral. That means here we have no charge. Here there is no charge. Okay. So for example, in SO4 2 minus, yes, here we have a charge. Yes, but here we have no charge. Okay. So this is neutral compound. Again, we know that oxygen in a compound, oxygen forms oxide ion. Oxygen remains as oxide ion in any ionic compound. Okay, so in this case also oxygen will be present as O2 minus. Okay, so that means this oxygen will give 2 minus charge. Okay, so since this compound is neutral, okay, so since this compound is neutral, so this 2 minus charge that is coming out of oxygen, this 2 minus charge that is coming out of oxygen, it has to be balanced. Yes, so who will balance this 2 minus charge? Copper will balance. Okay. So now if we make an equation out of this, okay, we will try to make an equation. So let us consider that the oxidation number of copper is X. Okay, and the oxidation number is also represented by the charge the copper ion will form in this compound. Okay, so let us consider that the oxidation number of copper is X. Okay, and or the charge of copper is X. Okay. And oxygen will give -2. Yes, because oxygen will form oxide ion, which is O2 minus. Yes. So, but we know that this overall compound is neutral. Neutral means it will have 0 charge. So now from this equation we can find what is X. So X is equals to 2. Okay. So that means in this compound the overall charge of copper only, okay, only of Cu is 2. Okay, so that means the oxidation number of copper, okay, oxidation number of copper in CuO is 2. That is, here copper was present in its metallic state. Okay, so that means when copper is present here alone, it is not forming any compound. So that means its oxidation number here is 0. Okay. And in CuO, we saw that oxidation number is 2. That is Cu2. Or you can write like this, Cu2. Okay, so that means what we saw, that oxidation number here of copper is increasing from 0 to 2. Okay, so what we saw in general oxidation process, the oxidation number increases. Okay, in oxidation process, oxidation number increases, and in reduction process, the oxidation number decreases. Okay, so how to find the oxidation number? Here, what you saw here, that is oxygen, it gives -2. Yes, because it from oxide ion, it will give -2 charge. Okay, but the overall compound is neutralized. Yes, the overall compound is neutral. So what will happen? This, since overall compound is neutral, the overall compound has a 0 charge. So let X be the charge from copper. Okay, so that means if, let us consider like this. This is copper oxide. Let copper give X charge and oxygen give Y charge. And we know X plus Y should be equal to 0 because here there is no charge. So no charge means 0. And we know what? Oxygen always form O2 minus. That means Y will be equals to -2. So putting this Y minus 2 equal X minus 2 equals to 0. So from this we can find what is X. Okay. So the value of X is the oxidation number of copper, and from this also you can say that if oxidation number of any reactant it increases in the product side, then we can say that oxidation is taking place. Okay, and if oxidation number decreases in the product side, then we can say that reduction is taking place. Okay. Okay, so I think now it is clear. Okay, so because in case of oxygen also, here you can see here oxygen is present as a covalent compound. Okay, so what is covalent compound, what are ionic compound, you will learn. So here the oxidation state of oxygen is also 0. Yes, but in this case also we are seeing that what give oxygen from oxide ion, which have a -2 oxidation state. So here happens, what happens, the oxidation state of oxygen is 0 in the reactant side, but it has gone to -2. That means oxygen, earlier its oxidation number was 0 in the reactant side. Now the oxidation number has changed to -2. That means the oxidation number of oxygen has decreased in the product side. That means there is a reduction of oxygen. Okay, so what you can see that copper is oxidized and oxygen is reduced. Okay, so from the oxidation number also we can say that whether a reaction is, whether there is an oxidation taking place or reduction taking place of a substrate. Okay, so you need not go into much deeper of what is oxidation number, because that is not required and it is also not required in your syllabus, but still I am giving you a brief concept about it so that you can know some of the concept of oxidation number. Okay, and it will be easy for you to find out the different type of reaction if it is asked that identify the redox reaction. So if you cannot find out directly, you can also take the help of oxidation number. Okay, so if you have any confusion regarding the oxidation number, you can ask me. I will try to explain it again one more time. Okay, and I think we have two very short topics, that is I think rancidity and corrosion. Okay, so these are very two short topics. So I will try to make a very short video on these two topics, and then this chapter will be over. Okay, and those two topics, video on those two topics, I will also try to post them during this current week, so that this chapter is over by this week. Okay, so that we can discuss the question answer then. Okay, so thank you, and yes, please subscribe the channel so that I will be discussing some of the questions that are already asked in your previous board exam after this chapter is finished. And since I will be uploading it in my channel, so you will get the direct notification of it if you already subscribe my channel. Okay, so thank you, and we'll meet on our next